Okay guys, so we're gonna start with some practice problems for series and parallel circuits. So we are given two 6-volt batteries and then two 2-ohm resistors. So I'm gonna write that down here at the bottom for my guess method. So I was given a total voltage, and we can just add up our battery. So 6 plus 6 gives me 12 volts. So we have a total voltage of 12 volts. We have our first resistor with a resistance of 2 ohms, and then our second resistor with a resistance of 2 ohms as well. So the first question that they're asking us for is what the total voltage of the circuit is. So we already found that just by adding our two batteries. So 6 plus 6 gave us 12 volts. So that's the total voltage of our circuit. So then we're asked what's the total resistance of our circuit. So we're asked to find our total. And since this is a series circuit, the equation that we use is the simple one in which we just add up our resistors. So our total is equal to R1 plus R2. So when we plug in our numbers, our total is equal to 2 plus 2, which gives me 4 ohms for our total. So what is the total resistance? Well, we just said 4 ohms. What is the current flowing through the circuit? So if we're looking for current, we are going to use Ohm's law. So let me put my triangle up here where it won't get in the way. So we have voltage up at the top, current on the left, and resistance on the right. So what is the current flowing through the circuit? To find our total current, which I'm going to put I total, the equation that we would use is the one for Ohm's law. So that would be I total is equal to V total divided by R total. So if V total we said was 12 volts and R total we said was 4 ohms, then our current flowing through the circuit would be 12 divided by 4, which is 3 amperes. So what is the current flowing through the circuit? 3 amperes. Then we're asked for the voltage drop across each bulb. So again, we're going to look at our triangle, and to find voltage, we multiply current times resistance. So we're looking for voltage drop across each bulb. So because we have two bulbs, we have one here, we have the second one there, that means that we have to have two answers. So I'm looking for my value for the voltage drop across the first bulb, and then the voltage drop across the second bulb. So my equation for that, for V1, would be I1 times R1. So my current, if we remember the previous video, current in a series circuit is the same throughout. So if our total current is 3 amperes, then our current across the first resistor is also going to be 3 amperes. So 3 times our first resistor is 2 would give me 6 for the first voltage drop. So if I want to find the second voltage drop, I'm going to do the same thing, but this time, since we're looking for V2, I need I2 times R2. So I2, remember we said that current stays the same in a series circuit. So I2 is still 3. I'm going to put this over here, 3. And then R2 is 2. So 3 times 2 again gives me 6 volts for V2. Okay, that was one practice problem. We can move on to the next one. So for this one, it's a similar problem. We have a series circuit again. We were given a total voltage of 9 volts, and then we have 3 resistors here. So let me write that down for my given. I was given a total voltage of 9 volts. My first resistor has a resistance of 2 ohms. My second resistor has a resistance of 3 ohms, and my third one has a resistance of 1 ohm. So my unknown here, they want us to find the resistance of the circuit. So they're asking us to find R total. Since this is a series circuit, R total is just equal to R1 plus R2 plus R3, and so on and so forth if we had more resistors, but we don't, so we can just end it there. So when we plug in our numbers, R total is equal to 2 plus 3 plus 1. So our final answer would be 6 ohms. So I'm going to write that in. My total resistance of the circuit would be 6 ohms. Then they want us to find the current flowing through the circuit. So if we're looking for I total, again, remember our triangle, we have V at the top, I on the left, R on the right. So the equation, according to my triangle, would be voltage divided by resistance. So I total is equal to total voltage over total resistance. So total voltage we said was 9 volts, and total resistance we said was 6 ohms. So we have to find our answer, 9 divided by 6, and that gives me 1.5. 1.5 amperes since we're finding current. And then they're asking us to find, again, the voltage drop across each resistor. So because we have 3 resistors and they want us to find the voltage drop across each resistor, we're going to have 3 answers. So we should have an answer for V1, for V2, and for V3. So if we're trying to find our answer for V1, we would look up at our triangle again. So to find our equation for voltage, it would be I times R. So to find V1, it would be I1 times R1. To find V2, it would be I2 times R2. And then to find V3, it would be I3 times R3. So we can start plugging in our numbers, and I'm going to show my work down over here at the bottom. So for V1, I1, remember it's a series circuit, so current is the same throughout. So current is always going to be 1.5 amperes. So this is V1 is equal to. Okay, so then we multiply it by R1, which we said was 2 ohms. So 1.5 times 2 gives me the answer of 3 for V1. 3 volts. That's our first voltage drop. So then for V2, I2 is the same, because remember current is the same throughout in a series circuit, and R2 is 3 ohms. So 1.5 times 3 gives me 4.5. So V2 is equal to 4.5 volts. Then last we have V3. So V3 is equal to I3, and remember current is the same throughout in a series circuit, so current is still 1.5, and then you're multiplying it by R3, which is 1. So 1.5 times 1 would still give us 1.5 volts. So these are 2 practice problems of series circuit, and then we have a few parallel circuits to practice on too. So here's our first one. It says a 4 ohm, an 8 ohm, and a 2 ohm resistor are connected in parallel across a 60 volt battery. So I'm going to start off by drawing my my circuit. So I'm going to start off with my battery, which they said was 60 volts, and we have 3 resistors in parallel, so I'm going to make 3 branches. There's my first resistor and my first branch, my second resistor and my second branch, and my third resistor and my third branch. So then our first resistor has a resistance of 4 ohms, then we have 8 ohms, and then we have 2 ohms. And so far this information I just got from the problem up at the top. So I'm going to go ahead and rewrite everything that I was given. So I was given V total, which was 60 volts. I was given R1, which is 4 ohms, R2, which is 8 ohms, and R3, which is 2 ohms. And so our first unknown is what the total resistance of the circuit is. So because this is a parallel circuit, we are using a different formula this time. So the formula for our total in a parallel circuit would be 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth, depending on how many resistors you have, but we only have 3, so I'm going to end it there. So then if I'm plugging in my numbers, it would be 1 over R total is equal to 1 over 4 plus 1 over 8 plus 1 over 2. So all I did was plug in my numbers. So I'm going to start off with adding up my fractions. So I like to keep my fractions as fractions. So to make that 4 into an 8, I multiply by 2. So 1 times 2 is 2. 1 over 8 stays the same. 4 times 2 gives me 8, so 4 times 1 gives me 4. So adding this up, 4, 5, 6, 7, I would get 7 over 8. So as I mentioned in the previous video, you can do one of two things. You can either put 1 over your answer, so that it looks like this, 1 over 7 over 8, or you can just flip the fraction that you had. I like to do that because it's easier for me. So instead of 7 over 8, I'm just going to keep it as 8 over 7. So let me erase so that we don't get confused. So I'm flipping my fraction 8 over 7, and I'm converting it to a fraction, or sorry, not to a fraction, to a decimal, and that decimal number will be my final answer. So 8 over 7 gives me 1.142857114, but I'm going to round it to 1.1 ohms, and that is our total. So I'm going to write my answer, 1.1 ohms. Then we're being asked for the circuit current. So all the circuit current is the total current in the circuit. So if I'm looking for current, I'm going to use my handy dandy triangle. So remember, we have V up at the top, I on the left, R on the right. So to find total current, I'm using the formula V over R. So our unknown is I total, like we said before. Our equation is I total is equal to V total over R total. So when we plug in our numbers, V total we said was 60 volts, and R total we said was 1.1 ohms. So I am going to plug that into my calculator. 60 divided by 1.1, whoops, gives me 54.5. So what's my total current? 54.5 amperes. Lastly, we're asked for the current through each resistor. So if you remember, current is not the same throughout a parallel circuit, and this is because the resistors in each pathway are different each time. So your current through each pathway is going to be different, because remember that current depends on resistance, just like we see in our triangle here. So if we have three resistors, then we should have 3 answers for this question, because they're asking for the current through each resistor. So I'm going to have an answer for I1, or for the current through the first resistor. We're going to have an answer for the current in the second resistor, and then for the third resistor as well. So for our equations here, instead of using I total is V total over R total, we would say I1 is equal to V1 over R1. So if I'm plugging in my numbers, and I'm going to do this one down here because I'm running out of room. So in a parallel circuit, voltage is the same throughout. So if total voltage is 60 volts, then the voltage through the first resistor is also going to be 60 volts. So this is I1 is equal to 60 volts over the resistance of the first resistor, which we know to be 4 ohms. So for our first answer for the current drop, or sorry, the current through each resistor for the first resistor, for our answer for the current through the first resistor, we would take 60 and divide it by 4, and that gave me 15. So for I1, we have 15 amperes. We would do the same thing for the next one, except we say I2 is equal to V2 over R2. So again, voltage is the same throughout in a parallel circuit. So V2 would still be 60 volts, but R2 would be 8 ohms. So now we're taking 60 and we're dividing it by 8. And that gives us 7.5 amperes. And then lastly, we do it one more time for the third resistor. So voltage is the same, it's still 60 volts, and we're dividing it by that resistance of the last resistor. So it would be 60 divided by 2. So 60 divided by 2 gives me 30 amperes. So what is the current? We would have 15 amps, 7.5 amps, and then our last answer, 30 amps. Okay, we have one more parallel example, so let's move on. All right, so for this one, we have a parallel circuit. We have 3 resistors, and they're placed across a 120 volt potential difference. So let's start by drawing our circuit. So we said that our battery has a voltage of 120 volts. We said that we have 3 resistors, so let me draw my 3 branches. 1, 2, and 3. All right, so then our first resistor has a resistance of 60 ohms, the second one has a resistance of 30 ohms, and the third one has a resistance of 20 ohms. So again, I'm going to rewrite all that in my given, just so that I can keep everything organized in my head. So my total voltage is 120 volts. R1, we said, was 60 ohms. R2, we said, was 30 ohms, and R3 was 20 ohms. So our first unknown is the total resistance of the circuit. So the equation that we would use, since this is a parallel circuit, is 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So if I plug in my numbers, I would get 1 over R total is equal to 1 over 60 plus 1 over 30 plus 1 over 20. So again, I like to keep these as fractions. So I'm going to convert them so that they all have the same denominator. So 30 times 2 gives me 60, so 1 times 2 is 2. 20 times 3 gives me 60, so 1 times 3 is 3. So then I can just add up my numerators. 3 plus 2 plus 1 gives me 6, and my denominator stays the same. So 6 over 60 would not be my final answer, because remember that we are going to flip our fraction. So if I want the reciprocal of my fraction, I'm going to flip it. So 60 over 6 amps gives me 10. So that would be my final answer. Our total is 10 ohms. So don't forget to flip your fraction if you're keeping it as a fraction. So what is the total resistance of the circuit? Our total is equal to 10 ohms. Then they're asking us for total current. So for total current, that would be I total. We have to go back to our triangle. So remember, V at the top, I on the left, R on the right. And according to my triangle, to find current, we have to divide V by R, or voltage by resistance. So I total would be equal to V total over R total. So remember that in a parallel circuit, the voltage is the same throughout. So if I have a total voltage of 120 volts, I don't have to worry about calculating voltage for my circuit because it's always going to be 120 volts. So 120 volts over my total resistance, which we just said was 10. So we take 120 divided by 10 and we get 12 amperes for our total current. So what's my total current? 12 amperes. And then they want the current through each resistor. So we're going to have 3 answers because we have 3 resistors. We're going to be looking for I1, I2, and I3. So if I'm looking for I1, then I need to take V1 and divide it over the value for my first resistor. So remember that voltage is the same throughout, so V1 is still 120, and my first resistor has a resistance of 60. So what is 120 divided by 60? That would give me 2. So for I1, we have 2 amperes. So now for I2, we're going to follow the same thing. I'm going to put my equations down here because I'm running out of room again. So if we're looking for I2, it's going to be V2 over R2. So just like we said before, voltage is always going to be the same. So 120 is still my voltage, but my value for my second resistor is 30 ohms. So now I'm taking 120 and I'm dividing it by 30. So that gives me 4 amperes for I2. And then last, for I3, we're taking V3 and dividing it by R3. So that's still 120, because remember, voltage is the same throughout in a parallel circuit. And then R3 would be 20. So now we're taking 120 and dividing by 20, which gives us 6 amperes. So I'm going to rewrite my answer. That would be 2 amps, 4 amps, and 6 amps. All right, one last thing before I end it. I want to go back and just kind of summarize with you the differences between series and parallel circuits. So I'm going to make a little chart here. So we have series and we have parallel. If we're looking at current for each of these, in a series circuit, current is the same throughout. For parallel circuit, that's not the same, but you can use Ohm's law. I is equal to V over R, or if you're given the individual currents, like if you know I2, I1, and I3, I1, I2, I3, then you can just add them up. So you would say total current is equal to I1 plus I2, and so on and so forth. For voltage, in a series circuit, it's not the same throughout, but you can use Ohm's law to figure it out. So you can use current times resistance, or again, if you are given the voltage drops, for each of your resistors, then you can say V total is equal to V1 plus V2 plus V3, and so on and so forth, depending on how many resistors you have. But in a parallel circuit, voltage is the same throughout. So if my total voltage is 90 volts, then my voltage across the first resistor is going to be 90. My voltage across the second resistor is going to be 90. My voltage across the third resistor is going to be 90. So for parallel circuits, we don't have to worry too much about voltage. So if we know total voltage, then we know what the voltage is across each branch. And then lastly, we have resistance. So for the series circuit, it's nice and simple. R total is equal to R1 plus R2 plus R3, and so on and so forth, depending on how many resistors there are. But in a parallel circuit, we have to put 1 over our total, and that equals to 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth. So this information in this little table is on Blackboard. There's a prettier version of it, but I wanted to fill it out with you so that we can really understand what it's saying. So I hope these videos helped you all. Let me know if you have any more questions, and have a great day.